Hi, welcome to the class. In the previous class we discussed about different forms of energies in which we discussed about potential energy, we discussed about kinetic energy and we defined them, we know how to calculate them and we derived an expression for potential energy as well as kinetic energy. Today we will continue with the same, that is we will be discussing about different forms of energies and the first thing which I will be discussing in the class is different forms of kinetic energy. So, what is a kinetic energy? Kinetic energy is the energy which is possessed by a body when it is in motion. So, when the body is moving, it possesses kinetic energy. So, basically a body can move or a body can show its motion in three different ways. Either it can move in a straight line, so that is what we call translational motion. So, when a body is moving in a straight line or doing translational motion, the energy which is possessed by this body, because it is moving, so that has to be a kinetic energy. So, energy possessed by the body which is moving in the straight line path or doing translational motion is known as translational kinetic energy. So, example of this type of kinetic energy is a ball moving in a straight line path, or a car moving in a straight line path, or a runner running in a straight line path. Now, the second type of kinetic energy or the second type of motion which can be possessed by a body is a rotational motion. So, you must have seen a fan rotating or a top rotating or a wheel rotating. So, all these objects, they do a different kind of motion, that is the rotational motion, but since they are moving, they must be possessing kinetic energy, because kinetic energy is due to motion. So, they must be possessing kinetic energy, and the kinetic energy which is possessed by the rotating objects is known as rotational kinetic energy. So, second type is rotational kinetic energy, and examples I gave you: a wheel rotating, a top rotating, a fan rotating. The last type is vibrational kinetic energy. So, in this type of motion an object vibrates. So, like you must have seen the string of a guitar. So, when you pluck the string of a guitar, it vibrates and it does a different type of motion, but it is a motion. So, the guitar's string must be possessing kinetic energy, and that type of kinetic energy is known as vibrational kinetic energy. So, this is these are the type of kinetic energies, that is linear or translational kinetic energy, rotational kinetic energy, or vibrational kinetic energy. Now, let us discuss about some different types of energies. The very first one is heat energy. So, what is the heat energy? Heat energy is the energy which gives you sensation of warmth. Okay, so it gives us sensation of warmth. Second type of energy, sound energy, it gives you sensation of hearing. Third type, light energy, it gives you sensation of seeing. We have different types of energy. Electrical energy is there, and we discussed about them. Now we will be discussing about the transformation of energy, that is how does transformation of energy takes place. That is energy, how does energy converts from one form to the other form. So, there are so many devices where we understand how the energy gets transformed from one form to another. So, the very first which comes to my mind is loudspeaker or microphone. So, in this loudspeaker, we all know that electrical energy to sound energy. Second, we can discuss about electric heater. So, electric heater is what? Again electrical energy to heat energy. And similarly, we have so many devices or so many phenomena where one type of energy gets converted into other type, like photosynthesis. So, in photosynthesis what happens? Light energy gets converted into chemical energy. Respiration, what happens in respiration? In respiration, so this is all about the forms of energy, And now let us discuss about a principle which is very important for us to understand, and that is the principle of conservation of energy. So what does principle of conservation of energy says? So principle of conservation of energy says that energy can neither be created nor be destroyed, but it can be transformed from one form to another. So it means whenever, in this case also loudspeaker, so it was one form of energy which was getting converted into the other form. But the energy cannot be created and it cannot be destroyed. It cannot be generated on its own. Neither it can be destroyed, but it will be transformed from one form to the other form of energy. So this is an important principle, and this is one of the basic fundamental principle of physics, where we understand that energy we cannot create, energy we cannot destroy, but we can just transform it from one form to the other form. So now we will be applying this principle to an important aspect, and that will be a free fall of a body. So when a body falls from some height, now since the body possesses some height, it must be having some kind of potential energy with it. So now we will now discuss the case of a freely falling body. So freely fall means a body is falling under the effect of gravity itself. So there is no force involved other than gravity. So if you drop a marker from some height, you have to drop it. So you just have to release it, and rest the gravity will take care of everything. That is, it will be under the effect of gravity itself. So a body which is doing a free fall, we have taken a body of mass m and we have assumed that the body is at a height h from the ground. So the body is doing free fall. So when the body is doing free fall, what happens is, we have taken the motion, we are considering the motion of the body at 3 points, that is point A, point B, point C. So we will start discussing from point A itself. So basically what we want to discuss here is that when a body is at some height from the ground level, we know that it possesses potential energy. So as it will start coming down, the height will start decreasing. So with the decrease in height, the potential energy will also decrease, but there will be an increase in its velocity. Why? Because of the gravity. So when there is an increase in its velocity, its kinetic energy will increase. So potential energy is decreasing, but there is an increase in its kinetic energy. That is, one form of energy is getting converted into the other form, but the overall kinetic energy will remain same. So this is how it works. So let us study the motion of this object of mass m at point A. So at point A, we know that the body is at rest now. We have not released the body yet. So the body is at rest. So there is no velocity which is possessed by the body at point A. So that is why the kinetic energy will be 0. Potential energy, it is at a height h. We know that potential energy is mgh. So the body will possess potential energy, that will be mgh. So the total energy possessed by the body will be k plus u. What is k? K is kinetic energy, which is 0 in this case, and what is potential energy? That is mgh. So you add up these two, so total energy will be mgh. Now at B, now the body has travelled a distance x from where it started. So the displacement done by the body, or the distance moved by the body from point A to point B is x. Now what is the height at which the body is now from the ground? So the body is at a height of h minus x, that is, h was the total height, x, the body has travelled a distance of x. So now the body is at a height of h minus x. So at B, what will be the potential energy? Obviously potential energy will be mgh, but in this case the h from the ground is h minus x, that is why it is mgh minus x. We multiplied this mg by h and then with x, so this will be the potential energy. Now I don't know the velocity of the body at point B. I have to calculate that velocity at point B. So kinetic energy is half mv square. So in order to calculate the kinetic energy, I should be knowing this velocity v, but I don't know what is the velocity at point B. So initial velocity I know, obviously it was 0 because the body was at rest, u is 0. How much displacement the body has done from A to B? X. So that is why s, which is displacement, is equals to x. And acceleration, obviously the body is falling under the effect of gravity itself. So the acceleration of the body will be g. So using this equation of motion, v square minus u square is equals to 2as. So V square velocity I have to find out. U is 0, obviously the body started from rest. Acceleration is only because of gravity, that is why G, and S is the displacement done by the body while moving from A to B, that is X. So V square is equals to 2gx. Now substituting the value of V square in the formula of kinetic energy, half mv square. So K is equals to half m into V square. So V square is 2gx. So 2 goes off, kinetic energy is mgx. So total energy, that is the mechanical energy possessed by the body, will be K plus U. So K is mgx, U is mgh minus mgx plus mgx goes off. What we are left with is total energy, that is total mechanical energy is mgh. So in the first case, kinetic energy was 0, potential energy was mgh, total energy is mgh. In the second case, kinetic energy is mgx, potential energy is mgh minus mgx, but the total energy is mgh. So as we can see in both the cases, the total energy remains constant or conserved. Although the one form of energy, that is potential energy and kinetic energy, keeps on changing from one form to the other, but the overall energy, that is the total energy, remains conserved. Now let us study at point C. Now what happened at point C? Obviously the body has come down near the ground or to the ground, so there is no height now. So this potential energy will be 0 and it will hit the ground with a maximum velocity. So that time the body will be possessing only kinetic energy. So kinetic energy will be what? Half mv square. So this is how the motion of this freely falling object is studied, and we have seen that one form of energy, that is kinetic energy, is changing into potential energy, and the overall energy remains conserved or constant. Thank you.